Welcome to our channel. Watch the video until the end. Leave a like and subscribe to support us. Europa is one of Jupiter's moons, still shrouded in mystery. We know about its internal and external structure, but many details remain to be explored. This celestial body in the solar system is characterized by an icy outer crust and an underlying ocean of salty liquid water. It is thought to potentially host life forms, possibly even macrofauna ranging in size from half a millimeter to 5 centimeters, making it an ideal candidate for the discovery of extraterrestrial life forms. Europa is one of the 79 confirmed moons of Jupiter, fewer than Saturn's over 80 moons. The first detailed images of this satellite were captured by the Voyager probe. Europa's surface is relatively smooth, dominated by plains and completely icy hills. It is about 780 million kilometers from the Sun, and average temperatures are extremely low, around 171 degrees Celsius. The internal heat of Europa, necessary to keep the underlying ocean liquid despite the low surface temperatures, is mainly generated by tidal forces induced by Jupiter's intense gravity. This process is known as tidal heating. Jupiter, with its enormous mass, exerts a strong gravitational pull that distorts Europa and generates internal heat. Europa is geologically active, as evidenced by plumes of icy material that emerge from its crust. This cryovolcanism, similar to terrestrial volcanism but with the expulsion of water and ice instead of magma, is a further clue to the geological activity beneath the surface. Europa's crust is relatively young and has few craters, indicative of frequent geological renewal. The Galileo probe, in 1995, detected a magnetic field around Europa, suggesting the presence of a conductive salty ocean internally. Recent studies suggest that this magnetic field could influence the movement of water within the ocean, contributing to the creation of a potentially habitable environment. The European Space Agency's JUICE, Jupiter Icy Moons Explorer, mission, launched with the aim of exploring Europa and other icy moons of Jupiter, will soon provide us with further data. The first close flybys of Europa are scheduled for 2032. Offering us the chance to learn more about this fascinating satellite and, perhaps, about the presence of life beyond Earth. The close flybys of Europa will allow us to examine the unique features of this moon more closely. Researchers will focus particularly on the reddish streaks observed on the surface, which could be due to the presence of salts and other minerals, perhaps transported from the underlying ocean through cracks in the icy crust. These features suggest complex chemical processes that could play a crucial role in supporting underwater ecosystems similar to those found around hydrothermal vents on Earth. Analyses of Europa's magnetic field and surface measurements could also confirm the presence of liquid water beneath the crust. Understanding the salinity and thermal properties of the internal ocean will be essential to determine its habitability. Additionally, geological studies of Europa could reveal whether conditions for life have been stable over time or if geological events like cryovolcanism have periodically altered the environment. One of the most exciting discoveries could come from the detection of complex organic molecules or even signs of past or present biological activity. Even if no current life forms are found, the discovery of organic compounds would significantly increase the likelihood that Europa could have been habitable in the past. The search for life on Europa is part of the broader context of exobiology, which seeks to understand how life can arise under conditions different from those on Earth. Every discovery made on Europa will help scientists formulate more precise theories about the origin of life in our solar system and beyond. As we approach the date of the planned flybys, the scientific community and the public await with great interest. The potential discoveries could not only reveal secrets about the evolution of icy moons but could also offer insights into how to search for signs of life on extrasolar worlds. In summary, the coming years will be crucial for our understanding of Europa and its potential to host life. With advanced technologies and a better understanding of its unique environment, we are on the threshold of potential revolutionary discoveries that could transform our view of the universe.